In this video, we're going to be talking about finding the zeros of a quadratic function. And so let's review how to actually graph these quadratic functions. So remember, when I graph, the first thing I want to look for is my vertex. So I'm going to be using that formula negative b over 2a. Well, in this one, our b is negative 2, so I'm going to do negative 2 over 2 times my a value here. Since there's no number, that's just going to be a 1. So if I'm finding my x value of the vertex, I get 2 over 2, which just simplifies to 1. Now remember, to find the y value of the vertex, we use our equation, y equals x squared minus 2x minus 8, and we're going to plug in 1 for every value of x. So 1 squared minus 2 times 1 minus 8, which is 1 minus 2 minus 8. And if I solve that out, I should get negative 9. So my vertex for this graph would be at 1, comma, negative 9. All right, so I'm going to go ahead and plot that point on my graph here, 1, comma, negative 9. That is my vertex of the graph. Looking at my graph, I also see that it's positive, so I know my graph is going to be opening up. And now I can use that table of values and I can fill it in to actually figure out those other points. So my vertex is always going to go in the middle, and then I'm going to find 2 points kind of on each side of that vertex. So now what I want you to do right now is I want you to pause the video and I want you to fill in the values for y there based on our x's. All right, so go ahead and pause the video and fill in that table just like we did in Objective 2. So hopefully you took some time to actually pause the video and try to fill out this table on your own. Remember, when we fill out the table, we're just plugging in each value for x and solving for y. And so now that I have this table filled in, I'm going to go ahead and graph this, each of these points. So negative 1, negative 5. I'm going to zoom into the graph here so I can see that better. Negative 1, negative 5 is going to be right around here. Our next point is at 0, negative 8, which is right here. Our next point is 2, negative 8, and then our last point is 3, negative 5. And so remember back to Objective 2, this should be symmetrical, right? So looking at our table of values and looking at our graph, what I'll notice here is there's kind of a pattern, right? It should be symmetrical. So our final step here to graph this is I'm going to draw that smooth curve through these points if I can. It's not going to be perfect, but as best as possible, draw that smooth curve. And your graph's going to look something like this, right? And so when I'm graphing that, again, 2 things that are important. You need to find your vertex, and then you need to fill in that table of values in order to get those points. Now let's look at one more review exercise, number 2. And this is actually going to take us back to something we learned last unit. So this one asks us to solve this quadratic by factoring. So let's remember back to last unit. We need 2 numbers that multiply to give me this last number of negative 8. And I want those numbers to also add up to give me this negative 2 here. So let's go ahead and list out our factors of negative 8. So what multiplies to give me negative 8? I know 1 times negative 8 does. I know negative 1 times positive 8, negative 2 times positive 4, and 2 times negative 4. So kind of listing those out. Well, remember, we need 2 numbers that multiply to give me negative 8 and add up to give me negative 2. So our 2 factors here would be 2 and negative 4. Because if I kind of test it out here, 2 plus negative 4 does give me negative 2, so it kind of checks out. So let's write out these factors right now. So writing these out, I have x plus 2, and I have x minus 4. All right, well, remember, if we have two numbers that multiply to give me 0, something that multiplies to give me 0, I have to set each of these equal to 0 to kind of set them, to solve them each separately. So I set this guy equal to 0, I set my other factor equal to 0, and now I just finish up solving. So I do get two answers. I get x equals -2 for one of my answers. And then if I add 4 to each side, I get x equals 4 as my other answer. And so we got our two solutions here. So the reason why I went over kind of that solving by factoring method that we learned last unit is I want you to take some note of something on the graph, right? Our two solutions for this equation, when I solve it out, are x equals -2 and x equals 4. I want you to take a second, pause the video, I want you to look at the graph we made and compare it to the solutions we have, and tell me what you notice. So again, pause the video and think about this. Look at your solutions we just got, look at the graph, and figure out what do we notice here. All right, well, hopefully you thought about this for a second. X equals -2, I kind of see is right here on the graph. I'm going to use a different color. And then I see x equals 4 is right here on the graph. What you'll notice is our solutions are actually exactly where the graph crosses the x-axis. And that is what we're going to be learning about in this lesson today. So those reviews were kind of just to get us in the mindset of what we're going to be doing in today's lesson. So when you think about the solutions to a quadratic equation, the solutions are actually where that graph crosses the x-axis, or also known as those x-intercepts. So in our first picture here, we actually have two solutions for this quadratic, right? Because that parabola crosses the x-axis twice. And so if you're looking for, okay, what are those solutions? The solutions, or zeros as we call them, are -2, right here, right? And +4. So our zeros here would be -2 and +4. Now looking at our next picture here, what I see is that graph only crosses that x-axis once. It kind of bounces off the x-axis. So for this one, there's only one solution to this quadratic because it only touches that x-axis once. And so what exactly is that solution? Well, looking at it, I see that the solution is 1 because that's where it crosses the x-axis. All right, let's look at our last example here, the last picture. Well, what I notice about this graph is that it never crosses that x-axis. Well, thinking about this, if it never crosses the x-axis, there's actually going to be no solution for this quadratic, and that happens sometimes where it never crosses. So what are the zeros for this? What are those solutions? There are no solutions for this one. And again, that happens when it never crosses or never bounces off that x-axis. So these are the three scenarios you're going to kind of run into. The most common one is where it has two solutions. The next common one you'll see is one solution, and then sometimes also it has no solution as well. So let's actually go through an example and identify these just based on the graphs. So moving on to example 1, we need to identify and label the zeros in each of the following graphs. So I already give you the graphs. All you need to do here is just label it right here. and identify what is my solution. So for this one, my 0 or my solution, there's just one of them, and it's at x equals 3. Well, for my next one, for b, what you'll notice is that it never crosses that x-axis, so this is one where there's no solution. And again, that happens whenever it does not cross that x-axis here. Looking at our last example, I see a point right here and a point right here where it crosses the x-axis. So my two solutions would be at 0 and at 4. All right, I want you to go ahead and pause that video right here, and I want you to try the your turn on your own. For this your turn, the directions state to identify and label the zeros in each of the following quadratic graphs, and then identify the vertex. So you're just going to look at those graphs, identify the zeros and the vertex. So take a moment, pause that video, try these on your own. Alright, hopefully you took a second to pause that video and try these on your own. So in the blue here we see those are our roots, our x-intercepts, our zeros. All these words here, I know there's a lot of words that we're using, but all these words here, roots, x-intercepts, zeros, those all mean the same thing. So I use those words interchangeably. That means those solutions, right? Where it crosses the x-axis, that is the solutions for the graph. So sometimes we use the word roots, intercepts, zeros, those are all words that mean the same thing, okay? So for the first graph, we see our solutions or our roots are x equals 1 and x equals 5, and I identified that on my graph because that's where it crosses the x-axis. Our vertex you'll see in red here, right? We've done this before. The vertex is just that maximum or minimum in that graph, and this one is a coordinate. The vertex is always written as a coordinate, and it is 3, -4. For our second example, our x-intercepts are at x equals -3 and x equals 1. Again, that's where it crosses the x-axis. And then our vertex is just at -1, 2. Our last one, I did identify that 0. That's at x equals -4. What I wanted to show you guys, though, is that vertex is also kind of at the same point, right? Our vertex is also right here. So our vertex would be at -4, 0, because that's where that graph starts. So when a quadratic only has one solution, the vertex, so kind of where it bounces off the graph, is going to be the same as a 0. That happens sometimes, that's okay. So hopefully this gave you a foundation of what zeros are in a quadratic, right? It's where it crosses the x-axis. So let's move on to go over another definition today. I want you to take a moment and try to answer this question. Suppose that you multiplied two numbers and the result is 0. What can you conclude about the numbers that you multiplied? So think about this. Suppose that you multiplied two numbers together and that result is 0. What can you conclude about those numbers that you multiplied? Well, let me give you an example. All right, so two numbers I multiplied together give me 0, right? I don't know what those two numbers are. Let's say one of those numbers is 3, okay? Well, in order for me to multiply to get 0, the other number has to be 0. Because in order to multiply and get 0, I know one of these numbers has to be 0. Whether it's the x, whether it's the y, doesn't matter which one. But when I multiply two things together, one of those has to be 0 in order for this to work out. Right, so this is called the zero product property. So let me give you the definition of that right now. So take a moment to write this down. If the product of two numbers is equal to 0, then one of those numbers must be 0. We talked about this a little last unit, right? That zero product property basically means if I have two things that we multiply together and they equal 0, one of those has to be 0. And we did that in our example as well when we were factoring. Okay, so one of those has to be 0. So I kind of set them each equal to 0 and solve them. So that's what we're going to be doing in our next piece. All right, so go ahead and get that definition down. We're going to move on to example 2. So now we're actually going to graph our quadratic on our own, and we're going to use the zeros to help us out. So let's start by just how we always start these, right? We always start by finding the vertex and plotting that on our graph. So remember, x equals negative b over 2a. Hopefully this formula's getting old by now. We've been using it so much. So we're doing negative, and then we're plugging in this negative 4 here. And then I'm dividing by 2 over our a value. Remember, our a value is 1 for this if there's nothing there. And so if I simplify this, I get 4 over 2, because the negative times the negative is a positive. 4 divided by 2 is 2. So I get our x value, the vertex. Now let's go ahead and plug it in and get our y value. So I know y is equal to x squared minus 4x plus 3. So I'm going to plug in 2 for every x I see. And so solving this out, I get 2 squared is 4. 2 times 4 is 8, and then plus 3. All right, if I solve this out, 4 minus 8 is negative 4. Negative 4 plus 3 is negative 1. Feel free to use a calculator to do this. And so our coordinate of the vertex is 2, negative 1. All right, so we're going to take a moment and we're actually going to plot this on our graph, 2, negative 1. So our vertex is right here. Now what we're going to do is we're actually going to factor and solve this quadratic by finding the x-intercepts. So I'm going to just write this down here, that x squared minus 4x plus 3. And just like we did in our review problem, we need to factor this now. So what multiplies to give me 3, and what adds up to give me negative 4. And so remembering our factors that multiply to give me 3, well, I could do 3 times 1, or I could do negative 3 times negative 1, right? Because a negative times a negative is a positive. And so if I think about, well, which one of these actually add up to negative 4, that would be this negative 3 and negative 1 here. So now if I go ahead and factor this out, I would write out, okay, I have x minus 3, x minus 1 equals 0. Right, that's my factors. And now using that zero product property that we just talked about and that we did in our review problem, I'm going to set each of these equal to 0 and solve them each separately, because I know one of them has to be 0 in order for this to work out. And so I'm going to go ahead and add 3 to both sides to get one of my solutions. I'm going to add 1 to both sides to get my other solution. And so these right here, right, what we just looked at on the graphs, these are our x-intercepts. So now that I know those, I can actually plot those points, and that makes graphing this a little bit quicker, right? Once I know those, x equals 1, x equals 3, those are going to go on my graph here, okay? And now I can kind of draw this quick sketch. Doesn't have to be perfect, but our quadratic is going to look something like this. So we plotted our x-intercepts, that's what we just did. We connect the points and drew the parabola, just did that, so we're done with this problem. So this is just another method we can use to graph quadratics. Always, always, always start with finding that vertex first. That's one of the most important parts of that graph. And then we can actually factor to find 2 solutions, and that's going to help us graph as well. All right, let's move on to our last example for today. So just like we did in Objective 2, we're going to graph these quadratics, and then after we graph it, we're actually going to identify the solutions. So now we're taking it one step further. I'm graphing everything on my own, I'm using that table, and then I'm going to look at the graph and see, okay, where are my solutions? So let's get started on example A. So starting with our vertex, negative b over 2a. On this one we have negative 4, that's our b value, over 2 times 1, because that's our a value. Right, so negative 4 over 2, which simplifies to just negative 2. That's our x value of the vertex. Now let's go ahead and plug this in to get our y value. So I get negative 2 squared plus 4 times negative 2 plus 4. So if I solve this out, I get 4, because negative 2 squared is 4, minus 8, because 4 times negative 2 is negative 8, plus 4. So solving this out here, 4 minus 8 is negative 4. Negative 4 plus 4 is going to give me 0. So my vertex is actually going to be at negative 2, comma 0. And I'm going to put that on my table right in the middle, and I'm going to plot that point right here. Okay, so let's go ahead and pick a couple points on the left side of that and a couple of points on the right side of that vertex. And now what I want you to do right now, go ahead and pause that video. Just like we did in Objective 2, we're going to fill in this table. You might need a separate sheet of scratch work, or you can just do it to the side here, whatever is easiest for you. All right, so we filled in that table there. Again, you'll see it's symmetrical. This should just be a review from our previous unit. And so now plotting these points, I got negative 4, 4, negative 3, 1. I already have my vertex in there, negative 1, 1, and 0, 4. And so if I'm plotting that, draw my smooth curve here. Okay, so looking at this graph, my last step here now, kind of the last step now that we added, is I need to find the zeros. Well, where does it cross or where does it touch that x-axis? Well, it only happens one time in this example, and I see that right here, right? So my zeros of this graph would be at x equals negative 2. So that's the solution for the graph. Remember, the solution, the zeros, the roots, all those words are interchangeable. That just means that x-intercept. All right, let's try example B now, kind of doing the same thing. So for example B, again, I'm going to start by just finding my vertex using that negative b over 2a. Well, in this one, our b is going to be 6, so negative 6 over 2 times our a value is negative 3. So solving this out, negative 6 over negative 6. A negative divided by negative is a positive 1. So now I have my x value of the vertex. Let's find our y. I'm doing negative 3 times, now I'm plugging in that 1 for x, plus 6 times 1. So anytime we see an x, that's when we're plugging that 1 in. And now let's go ahead and simplify, solve this out. 1 squared is just 1, so I get negative 3 times 1 plus 6 times 1, which is just negative 3 plus 6, which does give me 3. So my vertex for this would be at 1, comma 3. And I'm going to put that here, and I'm also going to plot that on my graph right there. All right, so now what I want you to do is I want you to pause that video, and I want you to fill in the rest of this table, if you can, on your own, right? So fill in the x values first, plug them in, and then fill in the y values. Pause the video. All right, so I went ahead and filled in that table there. And so now we're going to go ahead and we are going to plot those points. And so negative 1, negative 9, that is going to be way down here. 0, 0 is our next one. That's the origin. So that's right here in the middle. 1, 3, I already have plotted. That's my vertex. 2, 0, right here. And then our last one is 3, negative 9, which is right down here. And again, it should be symmetrical. That's a good way to check your work. I am connecting these dots with that smooth curve. And so what I see here are my two solutions. I have a solution here and here, right, where it crosses the x-axis. So I would label my two solutions, or x-intercepts, as x equals 0 and x equals 2. Those would be my two solutions. And so what we just did in that example is kind of like a culmination of everything we did this whole unit, right? In objective 1, we found the vertex. We did that there, right? In objective 2, we graphed this using a table. And then this objective, we were finding those zeros based on the graph we made. So this objective here is a nice review kind of everything we learned this whole unit. So what I want you guys to do right now is I want you to do both of those your turns here. Okay, there's only 2 of them. These are the last your turns of the year. How exciting. And then you're going to move on to that choice activity, that objective quiz, and then we have this test coming up, right? So go ahead and complete this last objective of the year. Good luck.